finding the equation of a line that passes through two known points. Now, let's consider the reverse problem, i.e. when the linear equation is unknown but we know 2 points of the line. These 2 points, say A, x1, y1, and B, x2, y2, help us find the equation of the line expressed in the form y equals mx plus n, in 2 steps. Step 1. Calculating the gradient m. Through the formula, we have the following shown on screen. Step 2. Substitute the value found in step 1 and the coordinates of one of the known points in the equation of the line to find the constant c. Let's explain this procedure through a couple of examples. Example. Find the equation of the straight line that passes through the points A, minus 1, 2, and B, 3, 4. B, A, 2, minus 4, and B, 5, minus 3. Solution. A. First, let's calculate the gradient m. Thus, from the equation of gradient, we have the following shown on screen. We obtain after substituting the known values, we have the following shown on screen. Now, we substitute the coordinates of any of the 2 given points, for example those of point B given that both values are positive. In the equation we have the following shown on screen, which already became we have the following shown on screen. This allows us to find the constant n. Thus, we have the following shown on screen. Therefore, the line's equation that passes through the 2 given points, we have the following shown on screen. B. The procedure is the same as in A. Thus, first, we find the gradient m, we have the following shown on screen. Then, we find the constant n by substituting the coordinates of any point in the line's equation. For example, let's choose the coordinates of point A, 2, minus 4, to insert into the equation. We have the following shown on screen. This allows us to find the constant n. Thus, we have the following shown on screen. Hence, for the equation of the line that passes through the 2 given points, we have the following shown on screen. That is all for lesson 14.3.3. To continue this tutorial, please watch 14.3.4, Finding the equation of a line from a given graph. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.